A chicken farmer decided to feed special pellets to his chickens to see if it made any difference to the numbers of eggs that they laid. He fed the pellets to the hens in shed A, but not to those in shed B. So these ones are getting the pellets, and these ones are not. They'd be the control group. He recorded the number of eggs laid each day in each shed for 2 weeks, and the results are as follows. Use your knowledge of statistics to comment on the use of pellets. So we need to comment on center, and we need to comment on the dispersion or the spread of the data. So I'm just going to pause recording while I type the data in, because that's not really, you've seen that in lots of examples before, and then we'll do the actual statistics. So I've now put all of the data in, and shed A is in list 1 and shed B is in list 2. So we're going to go calc one variable, list 1, frequency is 1, that's all good. So if we look at shed A, we have the mean at the top there. It's going to be 194.8. And what else have we got that's useful? Median is 197.5, and those are our measures of center. And then what else might we have? So standard deviation is 16.6, and we might work out something like the range and the interquartile range. So for the range, which ones am I going to need? I'm going to need max and min. So 214 take away 146. We'll do that calculation in a moment. And the interquartile range would be Q3, which is 205. Take away Q1, which is 192. And we'll work that out in a moment as well. And then we've got shed B. So let's click OK, and then we want to calculate the same thing for list 2. So let's look at the mean there. So the mean for shed B is 192.6. The median, since we're comparing everything, so the median is 196. And straight away we can then comment, because these are measures of middle, that the average is higher for shed A, although not by very much. And let's get some other values. So the standard deviation, so we want the sigma, so that's 26.6. And if we do the range and the interquartile range, just like we did, so we want the max at 228. That'll be take away the min, which is 145. And for the interquartile, we want 219, take away 166. So we just want to complete those calculations. So let's go to main, and if I do 214, take away 146, that gives me 68. And we'll do 205, take away 192, shouldn't really need a calculator for that, 13. And I've got 228, take away 145, which is 83. And then 219, take away 166, which is 53. And we can see the values are very, very different here to here. So more consistent. So although the mean doesn't vary that much, there's not a big difference in these, there's a very big difference in the spread. So we're getting a much more consistent product here. There's less variation in it, and that's what the dispersion shows us. And the standard deviation is consistent with this as well. The standard deviation, remember, is another measure of dispersion, and it's much bigger for shed B. So we can see with all of the measures of dispersion, we are seeing that we get a more consistent product.